All right, so again, I'm trying to count in base 5, and I've counted up to 125, which looks like a 1000 in base 5. Takes a little getting used to, feels a little weird. Reminder about what a base 5 number would mean, and we'll talk about base 10 numbers. So let's stick with base 5 here. Suppose I write a number like 2314 in base 5. I'm going to write this in what's called expanded form. And expanded means to name each place. Well, the 4 is in the ones place, so I have 4 ones there. The 1 is in the 5's place, so I have 1 5. The 3 is in the 25's place, so I have 3 25's. And the 2 we just figured out is in the 125's place, so I have 2 125's. So expanded notation is where you explicitly state what each place value is in addition to the digit in that place value. Right, so we have our digits 2 3 1 4, 2 3 1 4 with their associated place values. Another way I could state that is with exponents. So I could also write this expanded form as 2 times 5 cubed plus 3 times 5 squared plus 1 times 5 to the first plus 4 times 5 to the 0. Would be another way. Expanded with the exponents. And translating from base 5 to base 10 is just expanding it, naming each place value explicitly. I plug that into my calculator will tell me what this numeral means in base 10 number system, right? So whip out a calculator, make that calculation. What is this in base 10? Two 125s, 3 25s, 1 5, and 4 ones. 2 3 1 4, 2 3 1 4. I think I got all that right. 25 25 5 1. So I get in base 10, it's 334. Did anyone else get that? A couple nods. So converting from base 5 to base 10 is just expanding the number, naming the place value. So again, expanding is explicitly naming place values. All right, let's try the other way. We played around last class with taking a number in base 10 and trying to figure out what it means in base 5. So let's give that a shot as a review. Let's take the number 416. That's a base 10 number, and we want to figure out what is it in base 5. I'm going to pause here and let you play around with the ideas we had last class to try and come up with an answer. I'll show you a couple ways that I would do it in just a moment. If I did my arithmetic correctly, this is one way to think about the problem. Group base 5 is all about grouping by 5, and division is how we find groups of 5. So the first time through, 5 goes into 416 83 times with 1 left over. So there was one thing that wasn't part of a group of 5, but there were 83 groups of 5. Now, if I search that 83 groups of 5 for more groups of 5, I will find the groups of 25 and any remaining ones, and so on up the list. So what this is telling me is that, expanding this out, there is 1, 1. There are 3 leftover 5s. There is 1 25, and there are 3 125s. So this must be 3 1 3 1 in base 5. Now, I'm going to go and do that another way in case you find this method too weird. The other way to do it is like counting back change. You got to figure out what's the highest place value you need. The next place value after 125 would be 5 125s or 6 25. That's too big. So the other way to think about this is figure out how many 125s are inside 416. And if you check on your calculator, you'll find 125 goes in there 3 times. 3 times 125 is 375. Subtract 6 minus 5 is 1. 41 minus 37 is 4. So I have 41 left over, but there's the 3 125s. And then I keep going. I look at my next value. How many 25s live in 41? Well, there's 1 for sure. 1 times 25. Subtract. That's going to give me 16 left over. And there's my 125 up there. And then I say, okay, how many 5s go into 16? The remainder, right? 5 goes into 16 3 times. With a remainder of 1. And there is my 3 up there. And then there's my 1 1 hanging out the bottom. So there's a couple different ways to think about it. You can think about using the largest place value possible. And it's like counting back change, use the biggest bills first. Or you can think about repeating division and looking at the remainders, because division finds groups of, in this case, groups of 5. And the hardest part about either of these, I think, is getting the remainder, doing the division. And that takes practice on calculator and paper. I find I need both calculator and paper to make these happen well. Questions on either method? And I did a similar thing when I was playing with the Mayan. It doesn't matter what base I'm talking about. I just got to think in the right kind of groups to make it happen. And once I do that, I'm pretty good. All right, let's jump over to base 10 then. Back to base 10. And the point of these other bases is to just re-explore where our number system comes from. Why do we work with it the way we do? Base 10 involves 10 digits. Right? Our digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There is no single digit for 10 because 0 is very important. And then otherwise, we're grouping by 10. And when you group by 10, that leads to powers of 10. And those are the places, the place values. Important thing to emphasize here is the idea of expanded form. So let's pick 3,427 as our number. And we're very used to reading those numbers. We've had a lot of practice. Young kids are in various stages of development on this, but what we need kids to understand is that's not just a 3 and that's not just a 4, right? Ones, tens, hundreds, thousands, that's really 3 thousands and 4 hundreds and 2 10s and 7 1s. And this is what we call expanded form of a number. And there are toys kids can play with to try and wrap their minds around that. I have some here in the room. I have some others I'll show you online in a minute. Sometimes we do expanded form with exponents. So the exponential version of this would be 3 times 10 to the third, plus 4 times 10 to the second, plus 2 times 10 to the first, plus 7 times 10 to the 0. Again, expanded form is just to explicitly name the place values in addition to the digits in the numeral. Boy time. So if you're in the classroom, I'd recommend coming up here and grabbing some of these flat pieces. You don't need the big cubes. Grab some long pieces and grab some units. I'm going to show my Zoom friends and other internet friends the online versions at the Math Learning Center. I'll put this link in the chat and in the video. So I want the Math apps. And I want the number pieces. Chat is the link. To the beach. It's fine. When I first, now again, I need to emphasize this. This is super important. If I were working with kids in a classroom, I would absolutely not use this app. I would absolutely not do it. I would want the real toys to play with, for them to get a hang of it. I'm only using this because some of my students are online. Now, there are virtual academies out there in the world, like there's the Pendleton Virtual Academy here in the Pendleton area, hosted by the Intermountain Educational Service District. So they have kids that are doing online stuff, not hanging out with real teachers, which I think is a shame. However, I know there are some kids that it's a huge benefit for. So I'm not really dissing it. I'm just saying it ain't the same. Doing physical math versus virtual math. And I think too much screen time is not good for the human race. Anyway, on this particular app, there's a button in the bottom left with a few colors. I prefer this colored version of the app than the monochrome version of the app. Monochrome means one color, because then I can clearly see that these are my 1s and these are my 10s, right? You can see 10 of these make that. And then this is my 100. 10 of the long pieces make that. So sometimes we call these units longs and flats when we're talking to kids, but there's nothing wrong with calling them 1s, 10s, and 100s, because that's the number of little cubes that they're made up of. And again, the 2D versions of these on the screen aren't the same as the 3D ones you can hold on to and move around and play with. But it's kind of like the other day in class, we were playing with coins. So coins is a great substitute. Pennies, dimes, and dollars. Although we probably have fake money in the classroom. Did you get real money? I don't know. These are nice things. So what we're doing with these is we're just representing numerical ideas that kids might take for granted, might not quite get. For example, on the screen right here, I've just expressed a number. How much do I have on the screen right now? I have 111. Right? So I think this is a powerful thing for kids to really grasp what those digits we write down mean. So I'm just going to put up another number. And let's see, somewhere there's a zoom out button. Get to that one. That's better. So I can represent another number here and put them in any orientation I want. It's a little chaotic. All right. So here's my slightly chaotic number there. What number am I representing now? 234. So I'm just going to write that in here somewhere. There's a place to write Where did they put it? They rearranged these apps recently. There used to be a typing tool. There it is. Moved it up there. So this is 234 to the best of my ability. All right, I'm gonna mess with my number a little bit. Take that guy right there and I'm gonna explode it. All right, so I can move these around. How much do I have now? Still 234, but my representation is a little bit different. If I expand this out, what I see in expanded form is 100, and I now see 13 tens, and I see 4 ones still. But it's still 234. Is that a crazy thing to do? Rewrite it like that? 13 tens instead of, wasn't it better to use 3 tens with 100? Isn't that better always? No, why not?
It's just you give back money, you might get back biggest bill.
So we want to do that. Is there any instance you can see where we might want to call that 13 tens instead of 100, 200 and 3 tens?
You were dividing it among different things.
When you divide things up, you have to do that. Did anyone have to ever borrow in subtraction? Don't you do that in borrowing? Take some from a column and throw it into the next column? Yeah, so we can use the toys to demonstrate how the heck borrowing works. That it's not this mysterious thing of shifting digits. It's an actual physical act of trading in like $1 for 10 dimes. And it's important. Can you subtract without borrowing?
Most every number would have to be base 10 and rounded. We'd have to have every number end with 0.
Let's check that out. Okay, let's go do something like that. So this is 234. Let's do a little subtraction problem. I'm gonna come back to this.
Anything that's not a 1 or a 0.
So let's see, 234. So if I were to subtract something like, oh, sorry, stop it. 21, I can do that without borrowing, right? Yeah, I just take a little from each and they're okay. 234, how about minus 28? Can I do that without borrowing? Yeah. Okay, so write that down, do the work. I know you can all do it in your head, but I want you to write it down anyway and do the work. Back to this here. I like these toys because I can share. Let's get the link. Let's make it 4 of this. They have this nice feature where you can select a whole bunch of them. If you go back to where you started, here we go, and you can group them back together. Okay, so there's maybe the better way to write this. I'll flip that sucker right there. So here's my number, not as chaotic. It's like more organization. That's a cute version of it. So to take 28 from this, is that what I had when you go 28? Yeah. There's not 8 ones, so I would have to say, grab that guy right there, explode it. And now with those 4 and these 4 here, right, that's the whole borrowing idea. And now I can see, oh yeah, here's 28 that I can take. This group of guys, pieces right here, there's my 28. And then I can, once I take those away, I can see what's left. Right, so I should find that there is 206 left. That would work out too. Okay. So again, we can get physical about subtraction with the toys. It turns out there are other ways to look at subtraction. that there's a lot of countries in the world that don't borrow, which is kind of weird. And we'll take a look at this in the next section, but just a preview of it, it's kind of fun. One way other countries do this is they say, well, we can't take 8 from 4, but if that were a 14, we could do the subtraction. And instead of borrowing, they say, I just added a 10 to the top number. So what they do is they add a 10 to the bottom number to compensate. 14 minus 8 is going to give me the 6 that I want. 3 minus 3 is 0, and 2 minus nothing is 2, and I get the same answer. So that's a method called equal additions, and there's a lot of countries that do that instead. And it has some benefits, I think, that borrowing has some problems with that we'll look at later. But I can demonstrate that with the toys too, which is kind of fun. All right, so here's what I want you to do. We are now jumping into the next activity with this. This is activity 3.1b, which is a little easier than 3.1a. Here, I want you to start with 136 with the toys. And like I use the toys right now, just a minute ago, to rewrite 234 in a different way by expanding and trading in some blocks. I want you to come up with some different ways to use the toys to represent 136 things. And then write down the expanded version of them. Like one way is to grab 100 block, grab 3 10 blocks, and grab 6 1 blocks. What other ways could you do it? Do it with the blocks and then write the expanded version down. Yes, sir.
Do I have to write down the first one since it's done already?
No. I did the first one for you. You don't have to, but you could if you want. I need you to come up with 3 other expansions with the toys in mind. Base 10 blocks. Base 10 blocks. In this case, we have a 1 block, we have a 10 block, we have a 100 block. We're starting at the number 136. So I'm going to give myself a new screen to do this. Version. Way more fun.
I didn't look, is this how you did it? Just
Yeah, the first way I did it was the straight way, which is 1 and then 3 of these guys. 1, 2, 3, 4, 5, 6 of those. So I'm going to come up with 3 other ways to do it with these toys. So that's way number 1. So here's one example of another way to do it. I could trade a 10 in, and then I can say 136 is also 100, 2 10s, and 16 1s. Right, so come up with 2 more besides that, if you didn't do that one. And then once you do that, then you're going to make up another number, 3-digit number that you could use the toys with. I would recommend, maybe not 999. That's a little messy with the toys. And then show some different ways to expand it with the toys. So part 2 here is, again, you create a 3-digit number and then show two other ways besides the standard way to represent it with base 10 blocks.
So do we still need to list the first one, normal way to do it?
Yeah, list the normal way and then two others. Yeah, so you'll have three ways total, normal and two more. And for this second one, I would like a sketch of your blocks along with your expanded one for the second part. Or if you did it on the desk, take a picture. And give me the picture later.
So. I don't have a 36. One block.
Oh, you wrote that one down?
Yeah.
Okay. That's okay. I didn't ask for pictures of that. So-
But.
Pick another number to play around.
You have to show your sketches for both ways.
For your new number, yes.
So create a number, sketch it, and put 3 different ways to do it.
Three different ways to, yeah. So one way is the normal way.
Like what you did, number 1.
Yeah, and then come up with two other ways besides that for your number. Yeah. So here are two reasonably good representations of 234. I've got one more to do. This would not be good because the pieces aren't proportional to each other. All right, so that's, I made no effort to make them proportional. That's not a good representation of 234. Those are okay. Quick version about this one. I made my 100 block and then I just put strips in it. So I had enough 10s to make it 10 10s instead of 100. Quick way to draw that. All right, so that's this activity. You're probably done with it. You can turn it in today before you leave. Or if you're in Zoom, take a picture and send it to me. Or put it in the assignment. Try to set up the assignment correctly.